Welcome back to CAD Level 2 Assemblies and Design for Manufacturing. In the previous module, we introduced assemblies and connected our pair of joints together using a revolute mate. Now, we'll scratch the surface of an enormous catalog of nuts, bolts, and screws from the standard content library. When designing assembly systems of multiple parts, specifically in the context of designing something that is intended to be built, we often incorporate the use of fasteners. Bolts, nuts, screws, rods, whatever they may be, fasteners come in standardized sizes, something that you might pick up at your local McGuckin hardware store. While we, as CAD experts, could conceivably reverse engineer a screw and model it in CAD, a common feature of most CAD programs is a standard content library. This allows us to skip ahead and introduce common everyday parts into our model. Much in the same way that we inserted both of our joints into our assembly, let's use the Insert tool to find this standard content. The tab on the far right, Standard Content, opens up a slew of options. You'll recognize ISO as the standardized system that we used for making a metric M4 bolt hole back when we were making our joints. Further perusing this drop-down menu, we see ANSI, DIN, ISO, some familiar names. Again, ANSI, or ANSI, is the standard that uses the imperial system, or inches. DIN and ISO are our metric systems. DIN and ISO are the metric standards. Since we created an ISO standard hole in our joints, let's use the ISO standard. Now, let's start looking for bolts in the bolts and screws category. Next, select a class. If we peruse this drop-down menu, we'll get a small preview of the type of screw that we're interested in, down at the bottom of the window. There are lots of options. Hex bolts are fairly common, you've probably seen those before, but we have all sorts of options. I want to stick with a socket head screw. Finally, let's dimension the size and length of the socket head screw. Earlier, we said that we wanted to use an M4 bolt. I made this decision arbitrarily, but we can see that there are many different bolt sizes in the ISO standard. A really neat tool can be found right here, the Auto Size Fastener. If we click on this, we can select a circular edge or face, such as our hole, and it reports that our size is M4. Next, we need to determine the appropriate length of this bolt. We could place our component and guess and check our way through this, but let's use the measurement tool. If we click on one face of our part and the opposing face of our part, we see that the parallel distance is 1 inch. Granted, the lengths for the M4 bolt are reported in millimeters, since it's the metric standard, but you'll recall that about 25 millimeters is an inch. We might need to lengthen this a little bit, but for now, let's just leave it at 25 millimeters. When we press Insert, we see our bolt, along with a familiar icon. That little coordinate system icon is a mate connector. We want our bolt threaded through the whole of our joint, so let's place our mate connector where we know another mate connector exists, on the whole of that joint. When we click, we place our screw. Looking at the other side, we see that we haven't quite gotten all the way through, so we can't thread a nut on this. In order to address this, we'll have to edit the part that we just placed. So for now, let's accept our changes from the Insert Assemblies tool, go back and right-click on the hex socket head cap screw, and select Edit Standard Content Instance. Now, we can simply change the length and select Update. Now, let's add a nut to this bolt. Again, going back to our standard content, we can review a category of nuts. A standard M4 nut should do. Let's insert it and select the opposite side of our joint as the mating side of our bolt. You'll notice that these mate connectors can get kind of tiresome to look at. They get cluttered and they don't disappear when you use them. Let's right-click on one of the mate connectors and hide all mate connectors. There we go. Now, we have a nut threaded on our axle bolt. In our next module, we'll address this issue with tolerancing. We'll eliminate the overlap between our two joints, and we'll create some space for these parts to move around freely. We'll also create a counterbore for our hole, which will allow us to recess our nut and bolt axle.